Today we are going to start how the Java program will execute inside the JVM, and our topics are, which we will discuss, the Java compiler, which is the javac, and the Java launcher, which activates the JVM, and what is the JVM. And inside the JVM we have class loader, bytecode verifier, stack, heap, method area, native method area, interpreter, JIT, which is compiler, and a few interview questions. So let's start with today's session. Now, in previous video we start the basic program and we compiled it, which was the test.java file, and how it will execute inside the JVM. Today we'll discuss about that. So first we have to save our file with .java extension, which is a source code. Now this code in high level language. Now we have to convert our code into the native code. But in Java, whenever you compile your code, it will convert into the class file, which is a bytecode. Only Java can understand that code. So look at this image, the .java, and you have to compile your file with javac compiler. If there is any error, so you have to solve it. If there is no error, so the class file will be generated. Now, how you will execute? In previous video, we already see that we have to use the Java space your class name, which will activate the JVM. Now, what is the JVM? Actually, JVM is your Java virtual machine, and it's a platform dependent because every JVM is as per the machines. If you want a different, if you have Windows, so JVM will be different. If you have Linux, then the JVM will be different. Now, when you start your program, when you use the Java launcher, Java space your class name, it activates the JVM. Then what will happen? First, the class loader will activate and it will load your class file inside the JVM. Then after, bytecode verifier verifies the file. If there is no error and the code is proper, then your program will execute, and it compiled by the interpreter and directly sent to the DMA, direct memory access, or you can say that your processor or RAM. Now, what is the architecture of the JVM? You can see that we have the loading part, the class loader subsystem. We have loading part, linking part, initialization part, and runtime data areas, method area, heap area, stack area, PC register, native method stack, and the execution engine, interpreter, and JIT. Native method interfaces, garbage collector, and your host operating system. Now the thing, how the Java is platform independent, because your Java compiler converts your code into the bytecode, which is not a native code. That means which is not in a binary format. And your JVM decide at the time of execution which machine wants the output. Suppose that's your host operating system. If it's Linux, so your JVM will convert your code as per the Linux system, or if it's Windows, so it will convert as per the Windows. Now, if we are talking about the class loader subsystem, so what is that? The class loader subsystem create the instance of java.lang.class, and it performs three main functions of JVM, which is known as a loading, linking, and initialization. Now, bootstrap class loader inside the class loader subsystem, we have bootstrap class loader. What is that? It's load the classes from the bootstrap class path. Where is the bootstrap class path? It's inside your JRE. There is a folder lib. There is a rt.jar file. You can say that there is a core APIs are available. So bootstrap class loader is responsible to load all the core API classes. Extension class loader, which is also inside the class loader subsystem, it's load the classes present inside the ext folder, jre lib ext. There is some basic files which is required for your core Java program or your Java program. Then after linking, it's divided into the three parts: verify, prepare and resolve. And what is the initialization? Class variable are given their proper initial values. First loading happens, then linking and initialization. That means whenever where the values are available, it will initialize. Who will responsible for initializing the variable? It initialization part. Now come to the memory area, which is runtime data areas. So first one is a method area. It contains the class level data. What is the class level data? That means all the static variables and blocks, all the taken care by your method area. And heap area. Heap area contains the object. Heap area contains the object. And stack area. All local variable will be stored in corresponding runtime stack. It contains the frames as well. And what is the PC register? It's hold the address of current executing instruction. That means which task is executing at present, it will hold the address of that task. Then native method stack holds the native method information. For every thread, a separate stack will be created. Now come to the execution engine. Now we have interpreter and JIT. What is the interpreter? We all know about the interpreter. It's read the code line by line. So in Java, the interpreter read the byte code and convert it into the native code line by line. So and it's give it to the DMA, which is a direct memory access. Now what is the JIT? It's a just in time compiler. Suppose if we have repeated code and every time interpreter needs to convert the code into the native code. But in Java, if there is any repeated code, so JIT will generate the copy of that code, and whenever it's required, it will send to the DMA. So that is the benefit. That's why the Java program will fast. It's increase the performance. And garbage collector we'll discuss in next sessions. Now come to the interview questions. Now basic interview questions. The why Java is called platform independent language. But you can say that due to class file, Java is platform independent language. Now how? Because the java.class file, it's a byte code. It's not as per the machine, because Java works on Vora concept. Write once, run anywhere. So whenever you compile your code, it will convert into the byte code, and the byte code it's readable by all the JVMs. It's JVM of the Linux, Mac and whatever the OS, because JVM belongs to the Java and the JVM knows the instructions what is inside the class file. So that's why your Java is a platform independent language. Now another point is JVM platform independent. So simple answer, no. Your JVM is platform dependent because it's convert your code as per the machine. As per the machine, because the Windows, the internal structure of Windows is different and the Linux system is different and all systems are different in the different operating systems. So whenever you install your JRE, so JRE, it's a as per the machine. So that means the simple JVM is a platform dependent. And what is a just-in-time compiler? As I told you, it generates a copy of repeated code. And why does Java use both compiler and interpreter? As I discussed, interpreter reads the bytecode line by line and JIT compiler generates a copy of repeated code. Thank you everyone. If you like it, so please share it and leave the comments. Thank you.